The overall goal of this in vitro eye model is to simulate physiological tear volume, natural tear flow, air exposure, and mechanical wear produced during blinking to assess the performance of contact lenses.
This method can help answer key questions in the contact lens field, such as predicting the performance of contact lenses and related ophthalmic devices on the eye. The main advantage of this technique is that it provides a simple and cost-effective in vitro model to simulate multiple on-eye factors, which is currently not available.
Though this method is designed to provide insight into contact lens performance, it can also be used to test other ophthalmic systems, such as the glucose smart contact lens currently being developed by Google and Novartis. Visual demonstration of this method is important to understand how the eye model operates and how it can be used effectively in various research scenarios.
The eyelid and eyeball parts of the model are made from PDMS. First, prepare the PDMS. Using a syringe, transfer 10 milliliters of PDMS base into a 15 or 50 milliliter centrifuge tube. Then weigh out and mix in a 10% weight by volume addition of elastomer solution. Use a stir rod to mix the solution well. Now, pour the PDMS solution into the eyeball and eyelid molds. Fill the molds carefully to avoid trapping air bubbles. Allow the PDMS to settle at room temperature overnight, during which it will polymerize and small air bubbles will dissolve out of the mold. The next day, transfer the molds to an oven set to 75 degrees Celsius for an hour. Then, put the molds in a -80 degrees Celsius freezer for a few minutes.